Okay, good morning. The topic is about the directional coupler in the subject of micro and optical engineering. What is a directional coupler? Directional coupler is nothing about is a four-port passive device commonly used for coupling a known fraction of microwave power to a port, coupled port, in the auxiliary line while flowing from input port to an output port in the main line. The remaining port is ideally isolated port and match terminated. They can be designed to measure incident and or reflected power SWR. See the primary, secondary waveguides. Port 1 act as a primary and port 3 as secondary, and port 2 and 4 are act as a waveguides sections where coupling device has been mentioned in between the processing diagrammatic representation. The properties of directional coupler. So already said we are using the port 1 as an input primary port and port 3 as secondary. Now we are seeing about here port 1 as input port and port 2 as a received power and back power and coupled power are mentioned here with the main wave guides. With the match dimension at all its port, the properties of an ideal direction coupler can be summarized as a portion of power traveled from port 1 to 2 is coupled to a port 4 and not to port 3. A portion of power traveling from port 2 to 1 is coupled to port 3 but not to port 4. That is, directional wise, we are seeing the things. Properties of direction coupler, as already mentioned. See, as already mentioned, thing will be once again mentioning here. A portion of power incident at port 3 is coupled to port 2. Port 3 is coupled to port 2 but not to port 1. And a portion of power incident on port 4 is coupled to port 1, not to port 2. Also, port 1 and port 3 are decoupled as port 2 and port 4. Direction coupled indicates power. P1, P2, P3 and P4 as represented incident power, received power, back power and forward coupler powers as mentioned. Performance of directional coupler, coupling factor, directivity, isolation. Coupling factor. What is coupling factor? The coupling factor is for direction coupler is defined as the ratio of incident power to the forward power measured in dB. So 10 log of 10 Pi by P4, that is Pi by Pf, incident by forward. Okay, Pi1 to P4, that is port 1 to port 4 mentioned here. Whereas in directivity, we are seeing about the things. Directivity of direction coupler is defined as the ratio of forward power to the backward power Pb expressed in dB. 10 log of 10 is divided by P4 by P3. That is 10 log of 10 Pf by Pb. Whereas isolation is defined as the ratio of incident power Pi to the Pb, incident to backward. Isolation 10 log of 10 P1 by P3, that is I is equal to 10 log of 10 Pi by Pb. Types of direction coupler: 2-hole direction coupler, 4-hole direction coupler, reverse coupling direction coupler, that is finger coupler, and bead-hole direction coupler. 2-hole direction coupler. A 2-hole direction coupler consists of two waveguides, namely primary, secondary, with tiny holes in between them. The two hole at a distance of lambda g by 4 and lambda g is a guide wavelength. See, in this the two-port direction coupler as mentioned in the diagram: primary, secondary waveguides. Port 1, 2 and port 3, port 4. Whereas port 3 is cancelled section for port 1 to port 2. And the length is L is equal to 2n plus 1 lambda g by 4. Fraction of wave energy enter into port 1 passes through the hole is radiated into the secondary guide as the holes act as slot antennas. The forward wave in the secondary guide are in the same phase, regardless of the hole space, and are added at port 4. Backward wave in the secondary wave are out of phase by 180 degree, and the portion of first hole are called cancelled at port 3. The scattering matrix of direction coupler, it is a 4 port, so S is equal to 4 cross 4 matrix, and the direction coupler represented by the perfectly matched junctions, so S11, S22, S33, S44 equal to zeros. For a symmetric matrix already mentioned by the properties, Ij is equal to Sji, so S12 is equal to S21, like this, all mentioning properties will be mentioned. By substituting by the planes sections, we are obtaining S13 is equal to S31 is equal to 0, no coupling section, and no coupling S24, so S24, S42 equal to 0. By substituting those equations into the scattering matrix, S12 and S23 and S34 and S14 are mentioned, and other things are zeros. By applying those equations, by already mentioning our S into S transpose equal to I, so substituting those equations by the E plane T and H plane T we already constructed and derived out those equations. From those equations, we are obtaining out as JQ and P, where P is nothing about S12 equal to S34 and S23, S14 is equal to JQ, represented as imaginary axis. Yes, JQ is about nothing about imaginary axis. Okay, thank you.